Hello everyone, welcome to my YouTube channel and welcome to another video on the healthcare data analysis playlist. So on our today's video, we'll be carrying out exploratory data analysis on another healthcare data. Today we'll be looking at cancer data. This data set was gotten from Cargo, so you can search for the UAE cancer patient data set on Cargo and you'll be able to download the data set. So this is the data set. This data set contains information regarding patients in UAE. We have the patient's demographic, their diagnosis details, treatment information, health-related factors, and the outcome of their treatment. So as I said earlier, you can just search for this on Cargo and go ahead and download this data set if you would love to code along with me. Okay, I'll also be dropping the link on the description section so that you can click on that link and it will take you directly to the data set for you to download and code along with me. So I will just go ahead and close out of this and go back to my notebook. So in our today's project, we'll be carrying out exploratory data analysis. I'll be following some steps when it comes to analyzing data. We all know that EDA, that's exploratory data analysis, is a very important aspect when analyzing data, either healthcare data, business data, sports data, any type of data. Exploratory data analysis is a very important step, and exploratory data analysis covers you understanding the problem you are trying to resolve and the data set, importing and inspecting the data, handling missing data, exploring data characteristics, performing data transformation, visualizing the relationships between data, handling outliers, and communicating your findings and insights to the executive or your audience. So we'll be following these steps. I think there are up to 8 steps here. So we'll be following these 8 steps to carry out a typical exploratory data analysis of this data set. So if this is your first time being here, ensure to subscribe to my YouTube channel. Also ensure to share this video to your friends, loved ones you know are interested in analyzing healthcare data. So with that being said, let's dive right in. So the first thing we are going to be doing is import those libraries we will be using, right? So what are those libraries we need for analyzing our data? Pandas, NumPy, Matplotlib, and Seaborn for data visualizations. After that, the next thing we're going to be doing is reading our file into our Jupyter notebook. Remember, you've downloaded this data set, right? And it has been saved on your system. It could either be under your download section or your desktop section on your system, wherever it's been saved. So you have to read it into your Jupyter notebook. And how do you do that? This is the part to where this file is being saved on my system. So you can see it's saved under the download section of my system, and this is the name of the data set. Okay, and this is the additional extension, which is usually the type of that file. Is it a CSV file, is it an SF file, and so on. So we are going to be adding that extension to it, and with this you're able to read in your data set using the pandas.read_csv method. Now if you call the .head method on this data frame which we've read in, we'll be getting the first 5 rows of this data set. So you see we've gotten our data frame. This data frame contains various columns and numerous rows. So for now we don't know how many columns we have in our data set, neither do we know the number of rows, right? But we can see the different columns we have in this data set. Remember, this is an healthcare data. This is a data set containing patient information. So the first column is the patient's ID. This ID is used to represent the patient. Okay, so for healthcare data, instead of filling in the patient's name, we usually use IDs to represent those patients for confidentiality and privacy, right? So for each patient we have unique IDs representing each patient. So we have their various ages, we have the gender column where we have female, male, and probably any other gender. We have the nationality column, emirate column, the diagnosis date, that's the date a patient was diagnosed of having cancer, the type of the cancer, the stage, the treatment type. For treatment of cancer, it can either be radiation, surgery, chemotherapy, and etc. So the treatment type, the treatment start date, that's the date the patient started treatment, the hospital which this patient is taking the treatment, the primary physician, which is the doctor attending to this patient, the outcome, did this patient recover, is the patient dead, is the patient still undergoing treatment. So that's for the outcome column. The death date, this column is going to give us information regarding if the patient is still alive or if the patient is dead during the process of undergoing treatment. We have the cause of death, smoking status, comorbidities. Comorbidities are disease or medical condition that is simultaneously present with another in a patient. So for comorbidities, we're looking at what are those other diseases that was present when this patient had cancer also. So we'll also be looking at ethnicity, the weight column, and the height of these patients. So that's for importing and inspecting our data. The next thing we are going to be doing still under inspecting the data is looking at the shape of this data set. So how many rows do you have in this data set? How many columns do we have in this data set? To do that, we use the dot shape attribute to get this answer. So using the dot shape attribute, we cannot see that we have 10,000 rows in this data set and 20 columns. Another thing we can do to get further information regarding our data frame is using the .info method. So just as the name sounds, .info, it gives you more information regarding your data frame. Calling the .info method on our data frame, we'll be getting information regarding the number of rows, the number of columns, but also showing us the names of each columns, if they contain any null values, and the data type of the column. So for the patient ID column, now you can see we have 10,000 rows of data, meaning we don't have any missing value, right? Then it also tells us that the type is an object. Objects represent string value. Okay, so for the age, it tells us that we have 10,000 rows of data and it's an integer numbers. Okay, so gender, it tells us we have 10,000 rows of data and it's a string. So it gives us information regarding each column we have in our data set. So you can see for the death date, we have 992 rows of data, meaning we have missing values. So technically we'll be assuming that for those missing values, it represents that those patients are still alive. For the cause of death, we also have 992 rows of data. So the next thing we'll be doing on our exploratory data analysis is to handle missing data. Very important when you are analyzing data, any sort of data, either healthcare data, business data, sports data. You need to handle your missing values. Most of the times, not all data that are missing, or not all missing values in a data frame are actually missing values, just like our data frame we have right here. So to check for missing values in your data frame, you use the .isNA method, or some people also make use of the .isNull method. So you can either use this method or use the .isNA method. Any of these methods are going to work. Okay, and calling the .isNA method is going to return boolean values of true and false if you have missing values in those columns. But to get a sum, like you want to get the total number of missing values in that column, I'll be adding the .sum method on it. So I'm trying to say, okay, give me a summation of how many missing values I have in each of this column. So with this, you can say we have 0 missing values in these columns where we have 0 values, while for the death date we have 9,008 missing values. For cause of death, we have 9,008 missing values. So this information is actually corresponding with this findings we got earlier when we were using the .info method, right? So it means we are on the right track. Going on, For missing values, when it comes to healthcare data, not all missing values are actually missing values. Like in this situation where we have 9,008 missing values for the death date and the cause of death, you'll be finding that these missing values are technically where patients are still alive. So these patients are still alive, that's why there is no value for those rows. So for example, what I did here was just to get those rows of data where we have missing values on the cause of death column. Okay, so we want to look at those rows and analyze what we are getting. Is it actually true that all those rows of data are missing, or what's actually happening? So let's get to it. So you can see for the death dates rows, these are the rows we have missing values. When we look at this outcome, you will see recovered, meaning the patient did not die, right? So because the patient is still alive, there is no date of death and there is no cause of death, right? So you can see under treatment, meaning the patient is still alive. Okay, so that's where when it comes to missing value, you have to analyze your data. You have to look at your data. Are these values really missing, or there are more information I have to get from this data set? So imagine we didn't analyze this data and we just assume that since it said those values were missing values, we decided to drop those rows that were missing values. We'll be dropping a whole lot of information, a whole lot of valuable rows of data from our data set. So handling missing values, the way you are going to handle your missing values, is a very important step when it comes to analyzing your data. You should know what rows you have to drop, what rows you have to retain. Are those rows you want to drop, are they going to be bringing more insight into your data set, so that your actions you are going to be taking is going to commensurate to the insights you want to draw out from your data set? So for these missing values, I'm not going to be dropping them since they are not technically missing values, right? So I'll be leaving my data set just the way it is. The next thing I will be doing is to check for duplicates. There are some times when you are filling in data sets, the person who is doing the data collection might make mistakes. You might input a patient ID twice, or might put fixing a duplicate of a patient's information twice. Okay, so that's why we have to check for duplicates in our data set. Are there any rows of data that are occurring twice? So we can use the dot duplicated method to get those values, and we can call on the dot sum to give us a summation of any duplicates we have in the data set. So with this, you can say we have 0 duplicate values in your data set. In case in a situation where we have duplicate values, we would now go ahead and analyze those values and see, okay, are these really duplicate? And if they are, we go ahead and drop those duplicates from our data frame. So the next data cleaning we'll be doing is to convert data types. So initially, when we read in our data frame, you would see we have some columns of data where we have our diagnosis dates, and this should be in date data type, right? We also have our treatment start date, and also I think we the death date, right? The date the patient died. So we have 3 date columns, and if we look at the data types, we would see that these date columns were actually saved as strings. They were saved as objects. We would have to convert this to a date data type, because if we don't convert it, when we want to carry out analysis that are relating to dates, it will be difficult because it's here as a string or as an object date type. So how do I go ahead and convert this data to a date data type? The first thing I did was to call on the dtype attribute to confirm the data type of the column we should be converting. So for diagnosis date, we could see that it turns up that it's O, which represents an object or a string. So we'll be importing the library which we'll be using for this conversion. That library is the datetime library, and we'll be calling this as DT. So to convert this column to a date data type, we would have to call on the pandas to underscore date time method and pass in that column which you are trying to convert to a date object, right? So with this, we're able to convert our columns to a date data type. So you can see that it's not a difficult process, right? You just have to call on pd.store underscore datetime and pass in the name of that column which you are converting. I did that also for the treatment underscore start to date columns. Remember, we had 3 columns, right? The diagnosis dates, the treatment start date, and the death date column. So I actually left the death date column. So if you are coding along with me, you can go ahead and do that by yourself. The next thing I did was to now get a view of those columns which I have changed. So you can see I printed out our diagnosis date and the treatment start date column, and if I go ahead and check the type of this column, we would now find out that using the .dtypes attribute, we'll find out that these 2 columns are now date time data types. So the next on our exploratory data analysis is exploring data characteristics. So to explore data characteristics, I'll be creating categories from our age column. So you can remember that we have the age columns that contains the various ages for the various patients. It will be much more better if I group these various ages into certain age brackets, right? So for example, we can say from 18 to 35 years could be a young age. Then we can say from 36 years to 50 years can be adult age and all that, right? So this, the essence of this is that it's going to help us when we are trying to carry out data analysis. It will be much more easier for us to analyze age groups and compare it to various columns on our data sets than using individual ages like 30, 25, 60 and working with that column to compare or carry out analysis with other columns. So to create this age category, the first thing I'll be doing is using the nUnique method to get the unique age values. I want to know how many unique values do I have in this data set. So with that, we have 72 unique ages. Okay, so now we know the number of unique ages we have in this data set. The next thing I want to do is to get a view of these unique ages. So I'll be calling on the .unique method to get those values. So you can see we have 69, 32, 89. These are the various ages of our patients. And what's the reason of me doing all this is to help me when I'm trying to create those various categories or those various bins or groups. So this is going to give me information as to where am I going to be starting my range of ages from. So imagine I don't do this and I start grouping my data from 15 to, let me say, 30, and probably we check on this data set and there's no patient of age 15. Okay, so you'll see that my bins or age groups are not going to be very valid because we'll be getting some age brackets where we don't really have patients of that age within those brackets. So with that being said, the next thing I did was to call on the .describe method on the age column. So the .describe method is going to give me a statistical view of that column. I'll be getting the minimum values, the maximum values, the mean value, the number of rows we have in that column. So you can see the count, that is the count, the mean, the standard deviation, 25%, the 50% quantile, 75% quantile values and all that. So that's what the .describe is going to give to us. And with this now, I'll be using this information to go ahead and create my bins. So to create the bins, I'll be starting with the minimum age value. So if we look at this, our minimum age value is 18 years, right? So I'll be setting this as our minimum age value. Our maximum age value is 89 years, so I'll be setting this as our maximum age values. Then our 25% quantile is 36 years. This is going to be our 25th quantile. Our median value is 53. Our 75th quantile is 72. Okay, so these are the values I'll be using to create my beans that I will be using to create those various categories. The next thing is our labels. We need 4 categories. I'll be naming this young adults, middle age, older adults, and elderly. So what we're technically saying that for our young adults is going to be from the age of 18 years to the age of 36 years, while our middle age is going to be from 37 years of age to our median value, which is 53 years, while our older adult is going to be from 54 years of age to our 75th quantile value, which is 72 years. And same thing, our elderly is going to be from 73 to our maximum age, which is 89 years. So you see, this is a very easy way when you are trying to create categories. You can use the .describe method to create your beans and fill in your label values. So the next we'll be doing is to call on the .cut method now. So pd.cut, we are going to pass in the column which we are trying to create a category from, pass in our labels which we've created, our beans, and with this we're able to create a categorical column called the age underscore category. Now if I view this age underscore category column and our age column side by side, you can see we have 69 as older adults, 32 young adults, and etc. Now can I use this column, which is our age underscore categorical column, in carrying out data analysis? You can use it to explore relationships with other columns and look at the distribution of the age of those columns. So the next on our list is fixing inconsistencies. So in our data set, there are times where we have inconsistent values. So for example, there are situations where we can have, let me just make use of this column which we just created as an example. We can have older adults, then the person filling in this data, the data collector, might make errors and say older adult but using capital letter as A for adult. Okay, so there are situations where little mistakes like that happens, and if you don't correct that mistakes, they are going to affect your findings you are going to get from analyzing your data. So you can be going through the right steps when analyzing your data, but if you don't do some important data cleaning, you'll be getting the wrong answers. So fixing inconsistencies is also a very critical part when it comes to data cleaning. And how can you fix inconsistencies? The first thing is to find those inconsistent values, right? So how can you find those inconsistent value? What I did right here is to create a for loop. So I'm technically saying for x in each column in our data frame, I need the unique values of those columns. You can see, for example, for our gender column, we have female, male, and other. So with this now, I know we have 3 different genders in our gender column: female, male, and other, which is representing any other gender. Then we have the Emirati and expatriates correctly spelled. For the various Emirates, you have Abu Dhabi, Sharjah, Dubai, Ajman, etc. So you can see there are no inconsistent values. For the various type of cancer, we have liver, leukemia, lung, pancreatic, breast, ovarian, prostate, colorectal. So there are no inconsistent values. For example, if let me say we have ovarian spelled as capital letter O VARIAN, and maybe we saw another situation where we have ovarian also, but it was wrongly spelled, or it was correctly spelled but it was in capital letter, we would have to change those values and ensure that ovarian is taking one spelling and one style of write-up, right? So that is what I mean by fixing inconsistent value. So in this data set, if you go through it, you will find out that there was no inconsistent value. So since we don't have any inconsistent value, we'll be moving ahead to the next thing. The next thing we'll be doing now is carrying out a statistical analysis of our data set. So before we go into a deep dive into data analysis, there are some method you can call on your data to get statistical findings about your data set. A very important method is the dot describe method. The dot describe method, just like we talked about it earlier on, is going to give us a quick statistical insight of our data frame. So for example, calling on the dot describe method on this data frame is going to tell us the unique values, the top values, the frequency values, and one important thing about the dot describe method, that it differs the way it works. So when you are calling the dot describe method on a numerical column, it differs from the insight it's going to give to you when you are calling it on a string or a categorical column. So for example, if I want to call on the dot describe method on string value, I will have to pass in this argument stating that include should be equals to object, which is string values, right? So for string values, you can't really carry out mathematical operations, but you can carry out some operations, like you can count the most occurring values, the most frequent, that's the most frequent values, right? You can count the unique values, like how many unique values do you have in that column. You can count the top values and so forth. So that's what calling on the dot describe method on our data frame gives to us. So in this situation, it tells us that for gender we have 3 unique values, and earlier on you saw we have female, male, and others, right? It tells us that the top gender occurring is female and the frequency is 4985. It also tells us that we have 8 different cancer types. The top occurring is leukemia, and this is the frequency that makes leukemia the top occurring. Okay, so it gives us various information for various columns of data. So now you can say, oh, this is a table, is giving us a whole lot of information, but it's looking a bit stressful, to be scrolling up and down and trying to get to those insights. So a better way we can do this is to create a visualization, a graph that will be showing us the findings, right? So that's the next thing I did. I created a graph that will be showing us information, insights regarding those categorical columns. So for those columns I want to view is the gender, nationality of the patient, Emirates, which Emirates is the patient from, the cancer type, the outcome, did this patient die, is the patient still alive, smoking status, comorbidity, and ethnicity. So these are the various columns I want to look at specifically. So you could see I selected this column and I passed it into a list. The next thing I did now is to create a function. This function is called the plot underscore bar underscore graph. So from the function name, you will know we are plotting a graph that will be showing us the occurrence of each value in each column. If I go ahead and click on this, so let's get we can get a better view. You can see for our gender we have female, male, and others, and male is the most occurring gender. So this is confirming the information we got earlier, where we got gender, 3 unique gender, and the top gender as female. The next visualization is showing us the nationality, and we have 2, Emirati and expatriate, and you can see most patients were Emirati. For the Emirates, we have different Emirates. So where do these patients come from? You can see from this that most patients came from the Ajman Emirates, followed by the Fujairah and the Abu Dhabi Emirates. The lowest amount of patients came from the Ras Al Khaimah Emirates. I hope I'm pronouncing this right, because they are all sounding strange in my ears. The next thing is the cancer type. This is the next visualization showing us the cancer type. Which cancer type do more patients have? Leukemia. The next on the list is ovarian. Okay, we also have more patients with liver cancer, and for lungs, pancreatic, and breast, they are almost on the same scale. Also for the prostate and colorectal, so you can see they're almost on the same scale level. Okay, so for the next thing, we'll be looking at the outcome. How many of these patients are dead? How many are still alive? How many are still undergoing treatment? So you can see we just only have a few numbers of patients that have died from cancer. We have a lot who are recovering, and quite also more who are under treatment. The next is smoking status. You could see most of these patients are non-smokers. We only have a few who are smokers, while we have some who were former smokers but they don't longer smoke. The next is comorbidities. I have explained what comorbidities is earlier. I said it's a disease that is occurring alongside with the current existing disease. So for comorbidities, we can see that most of these patients actually had no comorbidity. So it was just cancer they were passing through. It was just cancer that was the occurring disease condition. Why some few had hypertension, others had diabetes, and a few had cardiovascular disease also. So the last graph is ethnicity. We can see most of these patients were South Asian. Then for European, African, East Asian, and Arab, they were most likely on same scale level. So using this visualization, you can see that we've gotten enough information regarding these various columns, information that we can just get at a glance. Okay, and you can see it's not as stressful as looking at this table. So let me go ahead and click on this so that we can get these deprecated. So the next thing I did was to look at our numerical columns. The only numerical columns we have in this data frame is the age column, the weight, and the height column. So let's call on the dot describe method on these columns. So calling on the dot describe method, you can see that our mean age is 53. The mean weight of our patients, or the average weight of patients in this data frame, is 69 kg, while the height is 169. Okay, so calling on the dot describe method, like I said earlier, is going to give us statistical information regarding the data frame. So with this, we can get the average, the standard deviation, the mean, the max, the 25% quantile, 50% quantile, which is also the median value, and all that. So the next thing I did also was to create graphical representation. You know, we said tables can usually be quite stressful when looking at them, but graph is usually pleasing to the eyes, and you can get quicker understand when looking at a graph. So we want to be looking at the distribution. When you are looking at numerical columns, one of the most important visualization is to look at the distribution of those numbers. How are the age values distributed? How are the height values distributed? How are the weight values distributed? So we'll be looking at the distribution of these columns. So you can see for the age values, we have ages from 18 to 90 years, or probably close to 90 years of age, and you can see how these values are distributed. It's not taking a bell curve shape, it's just being spread. Okay, so you can see some high values within age of 32 to 35 years. We can also see some high values between the ages of 75 to 77 years or so. For the weights, you can also see that our weights column is almost taking a bell curve shape. So you can see that most of the weight values are centered between 60 to 85 kg. Let me just use kg. Okay, while for the height, same thing, most of the values are centered between this point, which is from about 162 to 177 or 178 centimeters. So I'll be ending this exploratory data analysis here. I don't want the video to get too long so that it doesn't get boring. So if you want to see further analysis we made on this project, kindly drop the message next on the comment section, okay? And I'll do well to drop the next recordings. If you find this video educational and very informative, kindly do it to subscribe to my YouTube channel, like this video, ensure to leave that thumbs up. It keeps me pushing and gives me that ginger to create more videos. Drop your questions and comments in the comment section. I would love to know what you think about this project. Also, drop your recommendations on the kind of data sets you love for us to analyze next. Ensure to share this video to your loved ones, families and friends you know are interested in analyzing healthcare data. In this channel, we do everything data and healthcare. Bye for now and see you in my next video.